Hello all, welcome to another tutorial where we are going to see about how to do token classification with the help of BERT. Okay, so before going into the task, okay, so here is a sample of what we will be achieving in this task. Okay, so there is one sub task which is available in token classification, or else a type of token classification which is named entity recognition. Okay, so basically what is this named entity recognition is that in named entity recognition we'll try to recognize, and we might even say like extract. Okay, so we can say that we are extracting the entities from a given sentence. So in this sentence, I've written that Vasant lives in Chennai. Okay, so here the entities are that we have Vasant, which is a proper noun in terms of Pata speech tagging, but here we'll term it as person. Okay, Vasant is a person here, and then Chennai is a location. So it's trying to extract those from the sentence. Okay, so I hope now it makes some sense for you all about what we'll be doing in this video right now. Okay, so yeah guys, we are gonna start with our project right now. Okay, so unlike our other projects where I usually do coding in live, here what we are going to do is that we are going to kind of make a project code walkthrough. I'll try to keep it as detailed as possible, but the intention of this being walkthrough is that the tutorial can be slightly faster and the time of the tutorial can be reduced. Okay, so usually it is taking around an hour and a quarter. Okay, so like if we do in this way, maybe it will be reduced to 35 to 40 minutes maximum. So you will get a lot of information within a short period of time. So if you don't like these kind of videos, like walkthrough videos, you can also let me know about that in the comment section, where or else even I'll keep a poll after this video is uploaded. I'll also make sure there is a poll. Okay, I'll be asking a question whether you want coding or code walkthrough. Okay, so you can state your opinion there. Based on that, in our subsequent videos I'll make sure that either I'll do live coding or else code walkthrough. Okay, so yeah guys, that's for information. So now let's see what and all we'll be needing. Okay, so here we are doing our common installation, transformers, datasets, but these two might be somewhat new for you. Evaluate, yes, you would have seen in the previous text classification video where we used it to load accuracy, right? So generally what evaluate library is that we have kind of how can we put it, we have every metric, like not every metric, almost all metric which is needed for our training and evaluation. Okay, so what and all evaluation metrics we find in internet for NLP, it will be mostly available in evaluate library. Okay, again this is from Hugging Face. So another library is called CQL, where it is used to it is a type of metric where we use it for any tasks. Okay, so first we'll start with our imports and config section. Okay, um, these are all some conventional imports. Okay, not so fancy ones. We like not something new which we are seeing here. We have load dataset function from datasets, auto tokenizer, auto model for token classification. That is something new for you. Okay, and then data collector for token classification, that is also new. And otherwise, training arguments, trainer, these are all some old imports. So similarly, import numpy, SMP, and evaluate. Okay, so what is this auto model for token classification and data collector for token classification? So see, basically what happens is that when you have a model, it will happen is there will be out something called pooling output. Okay, so when the model is there, it will return some embeddings, and after that there will be something called task specific head. Okay, so in what happens is that that will try to provide our output format, and like that is where the model gets adapted to the same like some specific task, or else here we call it technically as downstream task. Okay, so like think in this way: BERT is a single model which is being able to train for text classification, token classification. In our next video, or one or two videos down the line, we'll be seeing about how to use BERT to create our own question answering system. Question answering system can be seen as a kind of a chatbot which can just answer your question alone, not in an interactive manner. Okay, so that also we'll be doing in some time. Okay, yeah guys, there are lots of projects which are planned in the pipeline. So if you haven't subscribed to the channel, please do consider subscribing to the channel, and if you haven't liked the video, please do like the video so that uh, the video will reach more people. Okay, and also share it among your friends. So coming to data set. Okay, so next, as far as data collator is generally your data loader. Okay, so data loader, what it does, it just tries to batch your data and then it tries to send the input. Okay, so here the data collator is customized for token classification task. So I hope I make some sense. And next we'll move on to dataset creation. Okay, so here conventionally we have a class name now as NER dataset. Since we are doing NER, we are doing just naming it as NER dataset. Okay, so what are all we are getting as input in NER dataset is that we need the dataset ID as well as tokenization checkpoint. Okay, now we are just keeping it in a variable called self.data_id, and also we are loading the tokenizer into a variable called self.tokenizer. Okay, I hope these are all some common things which you have seen by now. And then now for the load dataset function, where we are loading the dataset, we'll see which dataset while we are calling this class. Okay, in that we are taking the train and test alone. Okay, so that's why we have self.dataset of train and self.dataset of test. Okay, followed by this, what we have is in the dataset, or else in train, there will be some key called features. Okay, in that we are just calling the NER tags. So basically what happens is that usually we have B person, which is beginning person, and I person, intermediate person. There are a lot of different tags. I'll show you some samples. uh, this is another file. Okay, because here the custom uh, NER, I'll also show you how to do a custom NER by yourself. Okay, so this is just to show you some tags, like how a tag will look like. Okay, so here are some tags like BGO, BGP, beeper, IGO, IBORG, IORG. Okay, so BGO means B geolocation, beeper means B person, IGO means intermediate geo. Uh, okay, intermediate in between sentences, beginning of sentences, and org means organization, PR means person, geo means geology or location. Okay, so that is some custom dataset. I'll show you how to adapt this code itself to the custom dataset in the later part of this video. Okay, so we are just trying to find what are the NER tags which is available in this current dataset. Okay, and then we are just taking the names of it as a list, and we are returning all these. Okay, our train dataset, test dataset, and the list of NER tags. Okay, so that has been written here. Next, what we are doing is we are mapping a function called preprocess function. So here is our preprocess function. In preprocess function, we are first calling the tokenizer. Okay, so these are all some conventional ones, right? And here there is something unconventional. Is split into words equal to true. What happens is that here, rather than splitting it as subwords, it will try to split it as words, almost. Okay, and that is alone something different here. Other than that, it is similar to what we do previously. And then we have all our labels right now. So here what will happen is we'll also send our NER tags. Okay. So from that NER tags, we'll know like, what are the NER tags there. And based on that, we'll do a function called align labels with tokens. So I'll show you what is that right now. See, basically what happens is that when you have a line such that Vasant lives in Chennai, what happens is that it will try to split it into VAS, hash 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 ANTH, comma. These will be two tokens, and then live possibly hash 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 yes, and then in comma chen comma slash slash nai. This is about tokenization. Okay, so usually in dataset we'll have tags for words rather than your subwords. Okay, and also here there will be some special tokens called CLS and SCP, where CLS is called classification token and SCP is called separator token. These are all special tokens. Usually CLS indicates the beginning of the sentence and SEP indicates the end of the sentence. Okay. Um, so here in align labels with tokens, what we do is that we'll make sure that uh, the tag, the token, and subwords, the lengths match. Okay. So let's say if I have BAS, comma slash slash ANTH, and it should come beeper, right? So what happens is that here we'll make sure that both of this words or else the tokens will have the same token IDs. So that's the main idea here. And also if it is none, if uh, here the special token will be none. Um, these are all the effects of using is split words into words equal to true. Okay, so if it is none, we are just replacing it as -100 because this is a token which the training script will ignore while it is training. Okay, so what we are doing is we are just checking if it is a special word, and if it is not a special word or else the special token, we are just again seeing like if it is just none again as second level, and then we are just if it is not none, we are just getting the label alone. Okay, or else if it is again just none, then we are making sure that it is -100. And then once we have the label here, okay, exact label, we are just appending it to a list. So similarly again we are checking if it is special token. Okay, this is to just check again it is for a special token, and if it is special token, append -100. The first one was to check if it is start off with a new word, and then we are just moving forward because like I said, there is possible subwords, right? So next, if the word is similar to the previous word, okay, like same as previous token, so let's say like yes, we'll take even Vasant itself. So VAS slash slash ANTH, right? Here, what will happen is VAS might be recognized as B per, and then ANTH might be recognized as I per. So it will be combined together. So that's what it happens in this else condition. Okay. So it might sound so complex, but once you get the hang of it, you will try to be very easy, and you might not very complicate. This function remains the same for any data set you use. Okay, that's why I'll also show you how to adapt this code to custom data set, right? So you can see that this function would not be changed at all. Okay, so this function is like a template function. Okay, so yep. From this, we are getting the labels, and then we are just sending the tokenized input. Okay, so we are tokenizing the train data set and test data set. So once that data set is completed, next what we do is the conventional one. We are just logging in the data set. Logging in Hugging Face Hub, and you can just create a token in Hugging Face, and then log in from here. Okay, copy the token, paste it here, and you are done with that. Next we have our trainer. Now we have our NER dataset class where we are using dataset called CONLL 2003 and BERT based cased model. Okay, so how I'm saying this, here you can see we have data ID and tokenizer CKPT. Tokenizer is nothing but a model, right? So that's what we are using here. Now I'll show you how this data set looks like, which is our CONLL 2003 dataset. Okay, so yep, here we have CONLL 2003. Okay, so here you can see, right, it is having EU rejects German call to boycott British lamb. So here are some NER tags. So usually what will happen is, like, let's say the lamb might be splitted as lamb slash slash b. That's why we do this align labels token and all. The lengths might differ. To make sure that those are same and then aggregate it into a single one, we are just doing this align labels with token function. And like this, you can also see that you can also do post tagging and chunking. Okay, so post tagging basically is about part of speech tagging where you can say if it is a proper noun, common noun, etc. Okay, so yep, this is about the data set. Now let's again move on with our code part. Okay, so here you can see we are just getting our train and test data here along with the linear labels. So now what we do is there is another function called like another parameter rather called as id to label. Okay, so this you might have seen in our previous video itself where while we were doing text classification, we were giving a function called id to label. So basically what is the idea behind having this label is that uh, rather this id to label parameter is that when we send input to our model, it will be stating something like, 0, 1, because we used to classify by encoding it, right? When we encode it, it will be zeros and ones or something like that. And here, what it will happen is it will have a map stating that this label belongs to some arbitrary class. So rather than returning the number itself, the model will try to return the class. Okay, so I hope now it is making some sense. Okay, so that's what we are doing here. ID to label, where we are just going through in an enumerate manner, where we'll have an index and then a value. So we are making your index is to value. So it is just like passing as 0, 1, 2, 3, 4. So we are just also making that in a reverse manner so that the model will have both ways mapping. And then this function is for evaluating our model. Okay, so basically what it all will be getting is that we'll be getting precision, recall, f1 score and accuracy. Okay, so once we get our logits, we'll be performing an rmax function, and then we'll be getting the labels, and then also we'll be getting the predictions. And then it is just our normal way, like we'll compare both of those in the compute function, and then we'll get our metric. Okay, again, this is a standard, kind of a boilerplate code. You can just copy and paste it for any NER task, or else any token classification task rather. So in training arguments, we have just given output directory as BERT NER custom, evaluation strategy as epoch, save strategy as epoch, learning rate as 2e minus 5, which is 0.00002, and then weight decay, which is 0.01, and then push to hub, true. Okay, and epochs 3. So these are all again, we have seen this a lot of times in our video. That is the main intention why this video was made as a walkthrough video, so that we need not again and again do the same thing. Okay, so like I said, if you want live coding, I can also do you another thing, when we come to this kind of repetitive codes, I can just copy paste it. Okay, So yep, so here we have model and training arguments is given, eval data, training data, everything is given along with a data collator. Okay, so we have our compute metrics here as well as tokenizer is provided, and then once it is done, we are training the model. Okay, so I don't have Jupyter widget. It seems it is not able to render. That's fine. These were some like loading, but here it's the important part. At end of third epoch, we were having some impressive score, which is 90 F1 score. Yeah, 90 F1 score and also 97 accuracy, which is very good, right? And we were also able to see that it did perform very well. Okay. Uh, so yep, like you can also upload the as usual, right? I always make sure that you guys are able to execute the code which I give, rather than like executing it some paid version or company server. Uh, you can just upload this notebook as usual. Okay, so I'm just showing you. You can just upload it. I'm just closing it here. So you can just upload it in Google Colab and you'll be happy with what goes on here. Okay. Um, I hope NER is somewhat clear for you all. Okay. So now I'll show you some custom, like how to work on a custom NER dataset, and after that we'll move on with how to create an application out of it, which is very simple right now. Okay, with Streamlit in the field, it is very easy to make an inference application out of it. Okay, so let's move on with how to make uh, this code adaptable for custom NER. Okay, so here we have another function file called custom BERT NER. Okay, so here we are reading a file called ner.csv, okay, which I've provided here as well. And here we have POS, which is part of speech, and then we have the tag as well. Okay, so I've just got all the unique tags which is present in this. Okay, so once we have got all the unique linear tags, we are just making a function called tags to ID, which is nothing but your labels to ID. Okay, and if we do the reverse, it is ID to label, right? So that is something which you know right now. Okay, so the first step is get your NER tags and make a mapping out of it. So that's what has been done here. Second, what happened here was this is not something which you will see commonly in every dataset. What happened was when the dataset was found, what happened was rather than having it as a list of tags, the list itself was a string. Like you can say like I'll just write in nar. You'll have double quotes like this, and then you'll have a list. So it is like a string, a string with string of list. Okay, so we needed to have it in a list itself, so that we'll have every data, every tag inside a list. So what we used was there is a library called AST. Okay, so this AST model is usually used to process this kind of strings. Okay, when you have a dict in the form of string or list in the form of string or tuple in the form of string, you can just process it with the help of literal eval function. So that's what we are doing here. Like you can see the difference, right? I'm mapping it from a column called tag to tags, and here you can see it is having quotes here, but it is not having here. Okay, and then next we have map tags to id function. What is that? Like it is just nothing but your mapping directory. You have it right here. We are just trying to find the tags number. So here let's say if you have o, you have the number 0, right? So we are just building this column here. So see, what we are trying to achieve is that previously I shown you, right, like our CONLL, which is Cornell 2003 dataset. We are just trying to build a similar dataset. Okay, so the Cornell 2003 is kind of a benchmark dataset for your um how can I say token classification in here. task and all. So we are just trying to match that dataset format. So next what we are doing is here, uh, in that dataset you were able to see, right? Like we had a list of tokens or list of words rather, but here we are having a string. So what we were doing is we were splitting it. Okay, just had the splits function. So from there we will begin getting something like thousands of demonstrator have marched through. Okay, so like this we are getting the data set. Now once that is done, we need only these two columns, tokens and NER tags. So we just got that. Okay, tokens and NER tags. And once that is done, we were able to make a training data out of it. So you can just store it as parquet or else whatever way you want. I've shown you how to load parquets by using dataset dot from uh, pandas or else load dataset function itself. So you can load it in however way you want, and also make sure that you have that list of JSON stored. Okay, this mapping, because it will be very much needed later part. Okay, so we'll be having lot of adaptation only in our dataset side. Okay, so here you can see we are getting our train and test data path. Okay, so because previously we were getting everything from a single dataset from hub, but here we are loading it as separate datasets, right? Train NAR dot parquet and test NAR dot parquet. So that is there, and once we load that, so next, like you see, the align labels with tokens is same, preprocess function is same, and create data is also same. Okay, and here what is happening is that we are getting the NER dataset class, and then we are making train and test data. For NER labels, we are reading it from tags.json. Here, what happened was, to avoid any problem, what I done was that I made a list called NER labels. Okay, so in NER labels I had all the NER categories. Okay, so just I just made a key called NER categories, and then I had all the NER labels as a list, and then the similar process came down. Okay, we were processing uh, ID to label and label to ID based on this NER labels, like I shown in our common BERT in here, and there also we were getting some good accuracy, 96, but F1 score was not that great, but it is fine. 83 is not so bad. Okay, so there it was like, when I live in Chennai, it was able to recognize that Chennai is Geo. Okay, so yep, I hope this makes sense. Okay, uh, now in a short manner, we'll see how to make an inference out of it. So let's go. Now we'll need Streamlit, right? So import Streamlit as ST, and then we'll need some transformers import pipeline that is needed. Then st dot catch underscore resource. This is kind of a template, guys. You can mostly adapt to lot of scenarios. Okay, show spinner should work. Guess this should work. Okay, so what we'll do is we'll have a function. Okay, so in that, after that we'll be having, usually we should have a title for the page first. St dot title named entity, or rather we'll have it in a more stylish way. Keyword extraction using BERT. We'll have it as any task. Okay, so you can just give kind of a description out of it. Okay, if you want, like this task aims at extracting the key entities from the sentence. Okay, so next, once that is done, um, we'll have our load model function. I guess now this should work. Let's see. Yeah, see. Uh, so guys, if you are slightly confused why it didn't come previously but it is coming now, so for catch resource or this kind of catching function to work, you should have catching decorator. This is called a decorator. Okay, so for this decorator function to work, you need a function below that. Okay, so here what will happen is it will try to load the function in a catch. Okay, so here instead of load model we'll have as load pipe. What because we are using pipeline function here, but if you want you can also have it as model. Okay, that depends on us. Pipeline of token hyphen classification, comma, model is your model, ckpt, and then aggregation strategy. Here aggregation strategy will come, but usually you won't have it. Okay, so that is like, like I said, from aggregating from subword to word. That's why you have it here written pipe. Okay, next we have our inference function, def inference, which will take a text input. Okay, so what will happen is return let's say we'll call the function here by uh, token classification pipe is equal to load pipe of. Here we need to set our path, which is wasn't slash bird hyphen iner hyphen custom. Okay, so that is there. So once that is done, we'll return the return token classification pipe of txt hyphen t. Okay, so if underscore name, usually it is very good to have these as a class. We'll see that in a different video. Okay, so like how to make a template streamlit application for any NLP task. Okay, we'll make if you want that, you just mention in the comment section, guys. I'll make a video on that. There are some comments coming out, like to say how to build an inference application. Okay, so I've got for two different projects, they were asking me how to make applications. Okay, so if you want, just let me know in the comment section. So what we'll do here is we'll get um what we'll do is we'll make a input function, text input is equal to st dot text input. We'll make enter text, and then we'll have a button here just to make sure that it doesn't execute. People just sometimes match it with an empty string, but I prefer using this kind of uh, way. Okay, extract entities. Yeah, having a button like this. Okay, so if that is there, we'll do st dot write. Okay, st dot write of inference of text underscore input. Okay, so that is done, guys. That's all. We have our application here. We'll try to execute it. Okay, streamlit run. app.py. So it is now running. It is getting opened here. Okay. Like you see, it is showing running, right? I'll make this to that theme. Okay. uh, like you can see, right guys, to make this Streamlit application more beautiful, you can also use something called sidebar. Okay, so in that sidebar you can just give some description, images, your profile. Okay, everything can be given and that will look more beautiful. Okay, so the pipeline is getting loaded now. So yep, let's see. So it is now asking the same question, so I'm just going to provide the same uh, sentence. Okay. Awesome place in Chennai. Now it is trying to execute it. See, it came. Okay. So per Vasant. You can also make these look better, like calling these from how the output is going to be. So you can just parse the dictionary. But yep, you have your own keyword extractor using BERT. I hope this video is very useful for you. Yep. So now we know how to extract entities from a sentence by using BERT, right? So, yep, that's it for this video, guys. Okay, in the subsequent videos, I'll see you with our next video, our next topic in this playlist, which would be extracting question and extractive question answering. While we are doing that, it will be very interesting. So, yep, until then, bye.